Okay, so little switches.
Alright. Today, we're going to look at actually proving that triangles are similar. Right? So, we've talked about three theorems to show that triangles are similar. Angle, angle, side, 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 and side, angle, side. So, the easiest of those is definitely going to be angle, angle. Right? If I can show that two angles of two triangles are congruent, then I'm done. And I've shown the two triangles are similar. So that's what we're going to focus on today. It's just trying to prove that two angles of two triangles are congruent. So let's just go through a couple examples here. In this first one, we are given triangle ABC, and we're given that D is a point on AB such that, and E is a point on AC such that DE is parallel to BC. Okay, so that's kind of a long way of just saying that DE and BC are parallel. So we can start there. Right? We can say we know DE and BC are parallel. That's given to us. Well, if I know that these two lines are parallel, what angle pairs can I say are congruent? So, yeah, that would be one pair. I can say these two would be corresponding angles. Now, I would have to name this one using three letters, though, because there are multiple angle E's. Bottom E, like bottom E, and E. Yeah, that would be one way to name it. AED is congruent to ECB. Bottom of E? Yeah. This angle and that angle? Yeah. No, those wouldn't have any relationship because they're not on the same transversal, right? So these are our parallel lines. So any angle relationship is going to have to occur on the same transversal. So this is a transversal, and then this is a separate transversal. So this angle isn't going to have any relation to these angles over here. All right. So we've got one pair of corresponding angles. What else can I say? What other pair of angles can I say? Okay?
ADE and would it be? BDE. Oh wait a second. The ABC.
Yeah, we can call it ABC. So we can say angle ADE is congruent to angle ABC. Also because they are corresponding angles. We could, yeah. So we've got these two triangles here. Guys, these two triangles share angle A. So we could actually say angle A is congruent to itself by the reflexive property as well. But we've already got two pairs of congruent angles, so we actually have enough to say that these two triangles are similar. So we need to make sure we're writing a correct congruent statement. So we could say triangle ADE is similar to triangle ABC. Our reasoning would just be angle angle. So this one we only needed 4 lines. We didn't need all 5 of them. Okay, so the goal is just to prove two angles between the two triangles congruent, then we can claim they are similar by angle. Questions? Alright, let's do one more together here. So on this one, we're given a trapezoid. We want to prove that triangle, we have triangle triangle BEC is similar to DEA. So these triangles on the top and the bottom. So first, we know ABCD is the trapezoid. What do I know about trapezoids? That, yeah, one pair of parallel sides, right? So it's obvious which pair of sides in this trapezoid is parallel, right? BC and AD. So we can claim that. We can say BC is parallel to AD. And so, yeah, the reason that we can use is definition of a trapezoid. On a standardized test, you would probably see it written out as a trapezoid has one pair of parallel sides, something like that. A little bit.
BC and English.
I mean, he's saying, like, if it were like something like this, where it was a little harder to tell, like, no, not necessarily. I mean, we could just turn this sideways, and it would still be a trapezoid. So, no, there isn't really a good way to tell if it's not obvious. I mean, if it is something like this, hopefully they would tell you which pair of sides are parallel. But in this case, it is obvious which is a pair of parallel sides. So, what can we do with that then? If we know that AD and BC are parallel, so if we know it's an isosceles trapezoid, we could say the legs are congruent. But we don't know that for sure here. Yeah, that would be one thing we could say. These two angles are vertical, so we could say those are congruent. Yeah. So give me three letters to name.
B, A, C, and E, C.
Wait, you said BAC? So
I'm
this
in
angle?
B, A, C.
Okay. DAC. So yeah, this angle here.
And then B, C.
Yeah. Call them that. So angle BAC is congruent to angle BCA. What would our reasoning be for that? Alternate interior. So now we've got two pairs of angles congruent. I can now claim that these two triangles are similar.
Would BEA and CED work as vertical angles?
Yeah, those would be vertical. In this proof, that wouldn't really help us though, since we're trying to prove this triangle here is similar to this triangle here. But that would be true. They would be congruent because they're vertical. But now we've got two angles congruent in these two triangles. I can now claim they are similar. So we can say triangle EC is similar to triangle EA by angle. Questions? That's fine. So on the right side of your paper, there is just a summary of the three postulates we've talked about: angle, side, side angle, side. And then on the back is just some more practice proofs. All right. So do we feel like we're ready to try a few? I think they're the same.
Not necessarily angle, because if you prove triangles congruent, you don't have to write angle. So if you write side, do you have to write side?
That's a good question. I mean, I guess just to be clear, we could write similarity postulate. It's kind of implied though if we're stating that something is similar, that if we had like side here, that it would be the similarity postulate. But I mean, just to make sure that you're being clear, you could write similarity postulate there. Any other questions?